So here is the first example problem that I'm going to be doing for you guys. What I would strongly encourage you do is you pause the video here and you try out the problem on your own. If you'll note, this is no question that I've ever given you guys. This is just some other question that I came up with. So again, I strongly suggest pause the video, work as far as you can, ideally finish it, skip to the end and check the answer. If you got it right, awesome, skip on to the next problem. If you didn't, then come back to here and we'll walk through and see where that mistake was. So I'm going to give you guys a second or two to pause the video. And either you paused it and came back, or you just waited there for me to start talking again. So let's go ahead and try it out. First thing I always say is we need to make sure that we understand what's going on in here. So we've got Spider-Man at the top of a building. Again, I never claimed to be a wonderful drawer. There's Spider-Man at the top of a bridge. And he gets startled and drops his phone. So his phone is starting there. Let's go ahead and at least make it rectangular. Here's his phone. It's going to end up falling all the way down and hitting the ground. So let's go ahead and take a look and see, now that we've got this situation, the phone is going to drop from there to there. I'm going to call this position 0 because that's where it starts, and this position 1 because that's where it ends. So we need to figure out the initial position, we need to figure out the initial velocity, we need to figure out the final position and the final velocity. In between this time period, we have t0 to 1. And since I see that there's only one time period, I'm just going to call this t. Save myself a little space and a little headache. I don't have any additional time periods, and I don't have any additional accelerations, so I can just call this t, and I can call this a. The time it takes to go from up here to down here is 2.7 seconds. And then the acceleration, well, since it's in free fall because we just dropped the phone, we can say that it's 9.8 meters per second squared. At this point, we need to pause and decide on our axes. Remember, it doesn't matter what you call up. Up might be negative, up might be positive. It's all arbitrary and it's decided by you. Since most people are comfortable saying that down is negative and up is positive, let's go ahead and stick to that notation, which would mean that our acceleration due to gravity, because it's pulling it down, is going to be negative. We can fill out a little bit more information here. We know that he drops his phone, so if you drop your phone, you're not going to throw it up, you're not going to throw it down, you're just simply dropping it, which means your initial velocity is 0 meters per second. There's a little bit more information that we can fill out here. Depending on what you're thinking, you might either set the initial position to be 0 or you might set the final position to be 0. Based off of what I've seen in class, I've seen majority of people are more comfortable setting your initial position as 0. So we'll see what that ends up doing. But if you're really thinking about it, some of you might want to set your final position to be 0. And I'll tell you guys why that's going to be in just a moment. After we get this answer, we'll analyze it a little bit. So this first one, what we're looking for is how high the section of the bridge. So really we're looking for how far down it falls. Because if it starts up here and falls down here, then that's going to be what we want. So if we were to make some sort of chart that says what we want, it would be x1. And if we look at what we have, well, we have x naught, we have v naught, we have t, we have a. So we need to find some sort of equation that uses all these things. Technically, it doesn't have to have everything from this column over here. It just can only be comprised of these things here and what you want. So if you look over at your equations, the only equation that has x naught in it and these guys is going to be that this one over here. Your final position is equal to the initial position plus your initial velocity times time plus 1/2 acceleration times time squared. Ideally, what the first thing we do is we're going to plug in zeros. So x naught and v naught are both 0, which means this whole section goes away. And we're left with x1 is equal to 1/2 at squared. The next step that I would always say is make sure you rearrange to get the variable by itself. Since what we want is already by itself, then I don't have to worry about rearranging. All I have to do is plug in some numbers. So my final position is equal to 1/2 times my acceleration times my time squared. So I'm going to take a second to plug that into my calculator and do 0.5 times negative 9.8 times 2.7 squared, and I end up with negative 35.721. And since this is a position and we used our standard units, it's going to be meters. Now here's where some people might pause and say, hold on a second, Mr. Raymond, how can the building be negative 35 meters tall? And that's what I was saying about where you set your 0. Remember, this is your position. So as it falls, since we dictated that down is negative, its position is going to be more negative. So this is why I said some people might want to set the x1 as your 0 position. So it doesn't matter. Really, we find out that our answer to how high was this section of the bridge, well, that section of the bridge was 35.721 meters high. So regardless, you'll get the same answer, whichever one you set as your 0 position. Just one person's going to get negative, and they have to recognize that the question says how high was this section of the bridge. Well, the height of the bridge was 35.721 meters. If you chose x1 as your 0 position, then it means that you already came out with that positive 35. So there's that first question out of the way. Now we need to figure out what the phone's impact velocity is. So anytime you're talking about something dropping, everyone's first instinct is to say, well, the velocity at the bottom is 0. But that's not what they mean. What we're looking at is the exact moment right before it hits the ground. So we're not saying once it hits the ground and you wait a couple of seconds. We're saying as soon as it hits the ground, at the moment of impact, how fast is this object moving? So in order to do that, we can actually fill in this right here is now 35.721 meters, and since this is position, it is negative. So now that we solve for that, we can use that information and get a little bit more information on this. I always say try not to use information that you calculated just in case you made a mistake, but honestly there's some times that we might not be able to. So let's go ahead and take a look, see if we can get away with not using that x1. What we want is v1, and what we have is pretty much everything else. x0, v0, t, a, and then we have x1, but I'm going to set it off to the side because, again, I'd rather not use it if I can get away with it. And if I look at all of my equations, I end up finding out that I do have an equation that won't use x1. If we take our final velocity, it's equal to our initial velocity plus a t. So notice we don't have x1 in there, which means we're still using only information that they gave to us. So what I'm going to do is plug in my zeros, which v0 is 0. And then I would rearrange my equation. But again, we got super lucky here. We don't have to rearrange anything, which means we end up just plugging in numbers. So negative 9.8 times 2.7. And if I plug that into my calculator, I end up with negative 26.46 meters per second. So now again, I ask myself, what is the phone's impact velocity? Well, velocity is a vector quantity, so I do need to make sure that I have the correct sign on there. Since the phone is falling down, it makes sense that the velocity would be negative. So I end up with a final velocity of negative 26.46 meters per second. So again, list out what you have. We were able to get rid of the 0 to 1 because it was our only time point and it was our only acceleration, so we didn't have to worry about the rest of the things. Fill in everything you've got, make sure you draw a picture, list out what you want and what you have, check to see what equations work for that. and then plug in those numbers. We did the exact same thing for the second part of the problem. Again, we tried to ignore the x1 just in case we made a small little mistake.